Hello, my name's Avi Miller. I'm one of the product management directors for Oracle Linux. I'm here to talk about deployment of Oracle applications and more specifically about Oracle Database with Murano, and to give you a bit of overview of the Oracle OpenStack for Oracle Linux distribution. For those of you who haven't heard about it, I'll give you a brief overview about that and the methods that we're using to deploy Oracle Database. A quick show of hands, Oracle customers in the room. Couple Oracle Database users? Cool. So just quickly, I will be talking about future directions of Oracle products. As part of Safe Harbor, some of the stuff may appear, some of the stuff may not appear. Do not base your purchasing decisions on what I'm saying. Talk to your sales representatives, etc. So, what you will need to deploy Oracle products. We're using Murano. Currently our work is based on Murano, and I will discuss for those of you who are OpenStack aficionados. The first question is, why not Trove? There is a slide on that. There is a few slides on that, in fact. But what you actually need to do this, you need Oracle OpenStack for Oracle Linux version 3, which is currently in beta. So you can go and download that from the Oracle website if you want to check it out. It's based on OpenStack Murano. It is due for release real soon now. It is due for release apparently sometime this month, but before the end of the calendar year. But again, if you remember that safe harbor statement, you can't come and hit me if it doesn't get released. It's not officially my product. I don't get to officially state dates of release. But it's based on Murano. It is free to use, free to download, free to distribute. Go nuts, as is Oracle Linux. It is distributed as Docker containers as well. So we're the first enterprise OpenStack distribution to distribute as Docker containers, which we did with our 2.0 and 2.1 releases. We're up in our 3.0 now. It requires, Oracle VM Server 342, which has all of the OpenStack bits in it as well. So it no longer requires Oracle VM Manager. We can now manage Oracle VM Server with OpenStack 3.0. We also, of course, support KVM on Oracle Linux 7 as a hypervisor. We also support Hyper-V. There is a certification decision that you make as customers here. Oracle products are not certified on anything except Oracle VM Server. And certification is an interesting discussion. So if you want a certified platform, you need to run it with Oracle OpenStack for Oracle Linux and Oracle VM Server. If you want a supported platform, you can pick one of our other hypervisors that we support. We strongly advise Cinder volumes for database storage. You can use ephemeral for dev test, but I'm sure we can all spot the obvious problem with ephemeral storage for a database in production, because if the ephemeral storage goes away, so does your database. And you go, oh, that's sad. Obviously, from an Oracle perspective, we would strongly recommend you evaluate one of our ZFS-SAs or FS1 storage units. We ship the Cinder drivers for both of those with Oracle OpenStack for Oracle Linux. They're fantastic hardware storage options you may choose to evaluate. We use AF7 for storage management. This makes a discovery of storage in an OpenStack environment much simpler for us. And we strongly, again, advise don't use LVM for your Cinder storage in production. Use something real, like a ZFS-SA or an FS1, or a NetApp, if you must, I suppose. Okay. The big question, though, particularly at OpenStack conferences, is why Murano? Why not Trove? And that's our big question, and the one that we've actually spent a lot of time having to answer, of course, because we also have this other database product you may have heard of called MySQL. And MySQL is obviously the poster child for something like a Trove deployment. The biggest thing we had to resolve in this discussion is release scheduling. Obviously, OpenStack has a very fixed release schedule of OpenStack releases. Oracle Database has a completely different release schedule. Oracle Database releases themselves are actually spread quite far apart. But we release PSUs and CPUs every 3 months. And sometimes those can actually include additional functionality. So we will have patch sets for Oracle Database releases that actually bump the versions of an Oracle Database. So we need to decouple the release schedule. We needed to be able to expose new functionality in the database in the provisioning in OpenStack, and we needed OpenStack to not rely on a particular version of the database. We needed something to expose Oracle Database's feature set. So one of the nice things about Trove is that it is literally database as a service. It's great for that just give me a database functionality. But people buy Oracle Database and spend the kind of money you have to spend on Oracle Database for the functionality of Oracle Database. And we needed to expose that functionality as part of this provisioning process. For example, with the 12c stuff, the new container database and pluggable database functionality that we have, the Flex ASM stuff that we have. And we needed something, this is the Field of Dreams presentation, if you like. This is the if you build it, they will come presentation. In the Oracle world, none of the other Oracle products come to play in your yard until database is there. Because until database is there, none of the Oracle products actually work most of the time. So when we talk about getting Fusion middleware or getting WebLogic and getting any of our real software stuff, Siebel, PeopleSoft, NetSuite, those sorts of products up into stacks, they all rely on our database. So we need to get that in place first. And the nice thing about the Murano architecture is that if you look at the way it integrates into OpenStack, it only talks to heat. It only talks to the orchestration engine. It actually doesn't talk down to the compute and the network. It doesn't talk to Nova. It doesn't talk to Neutron. It doesn't talk to storage. It doesn't talk to Swift or Cinder. It actually just talks to orchestration, to heat. And that gives us a lot of flexibility around how we provision Oracle Database in this environment. I'm not going to go through that in depth, but what I will highlight is because we have all the data and logic in something that just drives orchestration, we can then do some really fun things around how that orchestration occurs with the individual images that we use. So if you look at the way heat works, it's basically, everything is a consumer resource node of consumers and providers. We've got a Neutron network. We've got a Neutron port, which talks to a Nova server, which talks to a Cinder volume. And they're all sort of discrete components that get either they provide a service, a Cinder volume is a provider of a block storage, or they're a consumer. And Nova server will consume a Cinder volume. It kind of makes sense. And you can define them based on those very fixed APIs. So I say, this is my network, my server consumes this port on this network and consumes this storage. It's all very great. And from a Trove perspective, a Trove instance is one instance. It replaces OS Nova, OS Computer, it replaces a whole bunch of stuff underneath that, which is great as database as a service, but it's not very flexible. It means that in order to get changes in, you actually need API changes into Trove. So you're lockstepped with the release cycle, and you need to do a lot more work in order for these things to get consumed, because you have to work upstream, they have to be accepted, et cetera, et cetera. With a Murano approach, we replace that single Trove instance with a compilation, if you like. That's my word, it's not an official word, but it's essentially a compilation of vanilla resources. Here we can just use orchestration to say, what I'm going to do is build up an application using a standard Neutron port, a standard Nova server, a standard Cinder volume, but I have slightly more smarts here, which I'll talk about in the Murano agent, in that I can drive the guest. I can tell it things about itself that it might not have known previously, and I can actually get that orchestration to work not just on resources from an OpenStack perspective, but from inside the guest. I can get the guest to know more about itself from higher up in the stack. And from Heat's perspective, and then again from monitoring and Ceilometer perspective, these are standard nodes. So if you think about an application, for example, if we were going to look at, Siebel as an application extending, a standard application type, Oracle database extending SQL database. You can have dependencies, you can have consumptions. There is a demo on this that I have as well that I'll show you. This is a 25-minute talk, so I'm not going to spend 10 minutes of it, trying to get things to clone as a database. But we do have a video demo that I can take you through this. We built, when we were building the Murano application container entry for database, we needed an application. So we used SwingBench, which is just sort of this load generator for Oracle databases as a token application, because again, as I said, nobody just has a database. They always have a database for something, and we needed the for something to test that our database provisioning was working. And the nice thing about this is that we can start to do some really fun things with chopping and changing items inside the catalog entry. And we'll look at this because we have, 2 operating systems. We have multiple operating system versions. We have multiple database versions. Creating a one-size-fits-all solution is never going to work for Oracle customers. So we needed a solution that was more flexible around chopping and changing the stuff. The other nice thing is that Murano agent. Okay, so one thing to note is that the Oracle database application catalog entry, the MACE, Murano application catalog entry, does require the Murano agent inside the VM. We will ship this as part of the Oracle Linux 6 and Oracle Linux 7 images. And it gives us that ability to drive VM and, node configuration, if you like. So when we provision the Nova node that will run the database software, we get to tell it what it is and what it connects to and how it starts up. So if we compare Trove and Murano, we're not slamming Trove. We like it. We obviously support it for MySQL. We're actually doing a bunch of development around Trove as well. But it supports the just give me a database because I'm more interested in the things above it functionality. It is lockstepped because if I change the Trove instance, I need to wait for API changes to hit the OpenStack services. It's released on a fixed schedule, and it's mitigated towards lowest common denominator. It's mitigated towards one-size-fits-all kind of thing with a very strict abstraction. We, on the other side, Oracle products, by and large, for those of you who've used them, are beautiful, unique snowflakes. And each version is a snowflake in and of itself. And one of the biggest problems that we have, I'll rephrase, one of the nicest challenges that we have as Oracle is each of our applications, for some reason, requires slightly different database configurations or slightly different database settings or slightly different parameters inside it. So we wanted a solution that would facilitate, once we started to automating the deployment of Oracle applications, the actual useful bits, to be able to drive a database deployment that fitted with the application being deployed. We also needed something that meant that we could be out of step with OpenStack's release cycle because database and OpenStack don't merge. So we needed something that we could ship at any time, that we could adjust for various database versions, and we needed to expose particular database features, and that loose abstraction was very, very compelling to us because, if we're starting to design a Siebel application deployment, a Fusion middleware application deployment, a PeopleSoft e-business suite, those sorts of things deployments, each one of those is going to have its own set of database requirements that we need to be able to drive through, which is pretty nifty. So if we look at the way we built this, which is how the architecture of the Murano entry came about, we have to take a step back and talk about the Oracle database template. Anybody here using Oracle VM? VirtualBox? Yeah, there we go. So possibly one of the most phenomenal automated templates I've seen across the board is the Oracle database template. It came probably 6 or 7 years ago because I deployed it at a very large bank here in Melbourne, down in Melbourne, about 6 years ago. And it started as a way of deploying real application clusters, or RAC, in a virtual machine. So it started with sort of this, how do I get RAC to work as a virtual machine? And it had very limited sort of automation. Now it is possibly one of the most phenomenal pieces of automation I've seen, in that it will build you an N-node RAC cluster using either version of the Oracle Linux operating system, 6 or 7, using any version of Oracle database from 11G-R2 up to 12C-R2, which is quite a thing, with N-node automated. All you have to do is give it a list of host names and IP addresses. So if you want to deploy a 100-node rack cluster, which we've done, by the way, only takes about 40 minutes. So you can have a running, production-ready, production-certified 100-node rack cluster in about 40 to 60 minutes, depending on how fast your storage is. And it will do all of the automation, including the creation of the VMs themselves. So we'll create the VMs, it'll configure the VMs, it'll configure shared storage, it'll boot all of that. It is fantastic. So we said, we've already got this template. All we're going to do is Muranoize it. I coined it here first. And And we had to make slight changes to it. We shifted the UID of the Oracle user so it wouldn't conflict with something like Cloud and Net. Tiny little changes. And that template consists of 2 disk images. It consists of the Oracle Linux operating system, the OS image, so either OL7 or OL6, and it contains the application disk. What is most likely going to happen here is we're actually going to split the database application entry into 2, one for the OS and then one for database. So what will happen is almost this triple dependency. The application will rely on the database will rely on the OS, which means you can decide when you deploy your database if you're going to deploy it on OL6 or OL7. So if you've ever worked through a Murano application deployment, I say, okay, I'm going to deploy the application. It says, okay, I need a database. I say, well, I'll pick a database. It says, I need an OS. Well, I'll pick Oracle Linux 7. Of course you would. It's the latest. Or I pick OL6 because my entire fleet's OL6. It's fine. My Exadata's run OL6, so I'll pick that one. We would like to hear from you, though, if you are Oracle Database and OpenStack customers. Would this make more sense as a single unified glance image? Like, do you care what the OS is at this point? There are different schools of thought on this one. Obviously, because upgrades and stuff still have to be done and considered, a lot of customers are still considering that OS requirement, so it does still make a difference. But in real application, in rack nodes where you could do sort of rolling upgrades and rolling patching, maybe that doesn't make so much of an idea. If you have thoughts on this, we'd love to hear them from you. So that automated install is completely automated through something called build cluster, which is now a misnomer because it also builds single instances. It started as build cluster, which is why it's still called build cluster, because we're nothing if not consistent. It will build a single instance HA using DataGuard, rack with DataGuard. It goes from a single node, very basic dev test environment, everything contained, right up to, I think our biggest test, so the guy who wrote it originally and still manages it is a guy by the name of Saar, based out of Oracle in Israel, and half the time he's in San Francisco. He did the biggest test with one of our new X610 boxes. I don't know if you've seen the Sun X610. I recommend playing with one if somebody gives you the option. It's a 10-socket, 10-core machine. No, 18. So 10-socket, 18-core machine. So each socket has 36 threads, so it has 360 threads, and we put 6 terabytes of memory in it. And then we ran, I think, 4,000 rack nodes on it, which is something you can do. Who knew? Okay. Just to test the scaling of deploy cluster. How would it break once we hit sort of those large binary numbers? Once we hit 256, was there something that didn't roll over? So we just kept going and going and going. That was using sort of flex ASM deployments and flex storage deployments, which is quite fun. So that all works. We didn't have to do almost anything from the database side. What we do strongly suggest Cinder volumes. For dev test, and a lot of customers are starting their OpenStack journeys in development and test, particularly in development, because it provides that self-service kind of style for the developers to spin up and destroy environments. We strongly recommend, though, that you use, if you're going to use ephemeral, because you might for a dev, if you're going to do particularly CI/CD stuff, so continuous integration and continuous deployment, if you're doing this kind of testing, you do sometimes actually really want to destroy the database every test cycle. You might want to consider shared storage. When I talk about shared storage, it's shared between the compute nodes, not necessarily shared between VMs, something like Ceph, which we also provide support for as part of Oracle OpenStack for Oracle Linux. Inside the template, we use ASM, and you need to configure the redundancy level. ASM either allows you to use external redundancy, i.e. you rely on your storage arrays redundancy, or it will do redundancy for you. So you can actually provision Cinder volumes from multiple storage devices, actual back-end storage, deploy multiple Cinder volumes, and actually get ASM to do redundancy across those Cinder blocks. And it can do high redundancy, which is, so normal redundancy is just RAID 1-ish. It makes sure there's always 2 copies of every block. High redundancy means that there's always 2 copies of every block in every availability group, and there have to be a minimum of 3 availability groups. So it becomes minimum of 6 copies. And then it does with high redundancy, it also does heat map movement. So as blocks get hotter and hotter in the database, they're moved to faster and faster storage. And ASM does all of that storage leveling for you. And I strongly recommend something like an FS1, which does storage-based leveling as well. I think my contractually obliged plugs have been done now, so I'll move on. So what you'll see, as I mentioned, Oracle OpenStack for Oracle Linux 3.0 is in beta at the moment. It is due for general release by the end of the year. The tech preview of the MACE, the Murano application catalog entry, will come out in the general release of 3.0. The actual underlying template is fully production certified and supported. It's just the MACE that's the text preview. It's just the automation that's a tech preview. And the reason we're doing that is because we want to get this into the hands of customers to fine-tune it before we say, okay, this is fully supported and fully baked. We want customers to tell us what works and what doesn't. We want the OpenStack community to tell us what works and what doesn't. And the nice thing about this is all free to download, distribute, upgrade, patch, use. You only have to pay Oracle if you want support for it. You actually want to phone us or email us for support. That's the first time you have to pay us. Otherwise, the whole thing is free to use, free to download, free to distribute. Go nuts. Some of the things that we're working on, where our development is focused at the moment. Currently, the database is a black box to Ceilometer, to the monitoring parts of OpenStack. But Oracle Database 12CR2 just introduced a whole bunch of RESTful APIs to access all the management information and analytics and statistics information. So part of the work that we're doing with the database team now is exposing that all to Ceilometer. So that if you see, this CPU, this VM CPU is at 80%, its I/O is through the roof. Why? Oh, because I've got an Oracle rack node running, and then I can see, cache fusion misses, and I can see, low-level table locks that are being held across rack nodes, for example. One of the biggest problems, by the way, we support, the MACE will go out with support for single instance, but not rack until we can fix this issue with Nova, being able to do multi-attached volume support. Obviously, Cinder can do it. And Nova, there are some workarounds. We can sort of add iSCSI devices into Nova volumes. We want it in Nova natively, so we're actually working with the Nova and Murano guys so that we can attach one Cinder volume to multiple nodes because, of course, rack requires shared storage. There's some caveats around this. Memory overcommit is not supported. The functionality doesn't even exist on Oracle VM Server. We've just never provided memory overcommit. It obviously does exist on our other supported hypervisors like KVM or Hyper-V. The first thing we will tell you if you're going to run Oracle Database, turn it off. Otherwise, you will find problems with Oracle Database. Use shared storage if you want to do live migration with rack. Obviously, we have this multi-attached thing to deal with, but CPU, you cannot overcommit CPU with rack nodes in production. Rack runs certain processes real-time for clustering, and if the CPUs are overcommitted, there is a strong chance your rack nodes will fence because they can't do their cluster stuff. So in dev test, you're probably not going to be using your rack nodes as often, so that's not an issue, but in production, we don't support overcommit. So where to from here? Where are we going with this? Database is the first step. If you build it, they will come. So the biggest thing for us from an Oracle technology perspective is, and before anybody argues that says, well, WebLogic doesn't require Oracle Database. No, I know it doesn't. But any application you run on WebLogic requires a database, by and large. All of the Oracle tech products do. Siebel, PeopleSoft, eBusiness Suite, all of those things do. Once we get the database is also, ironically, one of the least complex applications to install. It may be quite complex to run in certain circumstances, but from a deployment perspective, it's actually fairly well known. It's our oldest product by far. It's our most automated product as well. We get this right, and we have the building blocks to start with the other applications. We start focusing, and we can say to them, okay, we've got the database. The irony, of course, is the flip side is that every application that comes into the catalog will have an external database option as well, so that you don't have to deploy the database into OpenStack because we have these lovely things called Exadatas, and we'd gladly sell you a database appliance, which is magnificent, which also does all of its databases and service stuff inside the appliance. So, of course, every application needs to be able to point to external stuff. We need to get this right. once we've got the database working, we have a platform on which we can deploy other Oracle products. We're very, very interested in working on a reference architecture with Oracle Database with the community as well. And we've done a lot of work around standardizing Oracle Database deployments to get this right as well. So again, probably another reason why we're doing a tech preview of this instead of a first GA release is that we can work on the reference architecture at the same time as well, so that when it becomes generally available, hopefully it'll be generally available as the reference architecture as well.